Okay, this is the next unit, Unit 4, trigonometric functions. We're going to be studying basically graphs of trigonometric functions and what happens and characteristics about those graphs. The first one I start out with is the sine graph, and there's a direct relationship to the values on your unit circle. So let me show you just a quick sketch of the unit circle. If you look at these points here along the x-axis and along the y-axis, the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Those are the only points I'm actually going to even worry about to plot this sine graph. So I notice that everywhere that sine is 0, pi, 2 pi, 3 pi, and so on. So all the multiples of pi, the sine value is going to be 0. And that keeps going forever. Whether you're going clockwise or counterclockwise, it doesn't matter. Then what happens is I have this point 0, 1, and this occurs at pi over 2. So at pi over 2, sine is 1. Then I come over here to 3 pi over 2. The sine is negative 1. If I keep going, this is 5 pi over 2. And the pattern continues, so I could go in both directions. So these are the key points that I would need to graph my sine wave. And I'm just going to go ahead and connect them with a smooth curve. I'm putting arrows on it because it does continue to go. So the domain on this is going to be all real numbers. It just keeps going right and left forever. But the range, the sine graph does not ever go below negative 1 or above a positive 1. So that's why the range is negative 1 to 1, and it includes them. When we're talking about an amplitude, we're talking about the maximum, which is here, the minimum, which is here, and half that distance is the amplitude. The period is a vertical, or is a horizontal distance. So if I start here at 0, I start to go up, down, back up, and back to where I start. It's like the whole unit circle. So my period is a horizontal distance. And it's 2 pi over b. So in this case, this distance on this graph, which will be our parent function, is 2 pi. And my amplitude, this distance from negative 1 to 1 is 2. Cut it in half, it's 1. And then the key points, like I said, are the x-intercepts. So all these values right here. My maximum and minimum points. Here's a maximum, here's a min, max. And then we do translations. And once again, students tend to be really strong in this aspect of it. So if I start out with y equals sine x minus c, it's going to move it right c or left c, depending on what the value of c is. So if I did y equals sine x minus pi, I'm going to go right pi units. So I always start at the origin, and this faint line that you can see, this green line, is the parent function. So if I move that right pi, and I move everything right pi, I'm going to end right up on itself. If I take this maximum and move it right pi, it goes here. This minimum and move it right pi, it goes here. So this pattern then continues. And it looks like that. I can move up or down as well. So if I wanted to do, let's do y equals sine x And be careful, I do not have parentheses around this x and this 1, so they don't go together. So this is going to go up 1. So I always take, and I mark my x-intercepts first, move everything up 1, and then connect it with a curve. Okay, we can do x and y-axis reflections. Y-axis reflections don't tend to occur. Let's do an x-axis reflection. So I've got y equals negative sine x. So an x-axis reflection, all my x-intercepts stay the same. Everything below the x-axis comes above. Everything above goes below. So you can see, you can't tell if this was an x-axis reflection or like the one I did over here, which was right pi. So you can get the same results multiple different ways. If we did a y-axis reflection, that means this half hump is going to come over here, this half hump is going to come over here. So what happens is that an x-axis reflection and a y-axis reflection ends up being the same graph. So in that case, I would have negative sine x is going to equal sine and negative x. And we've not talked about it a lot this year, but in other years we do. So negative f of x equals f of negative x. That means it's an odd function, and it is origin symmetry. And we can continue this idea with transformations. Here's one if I change the value of a. So let's make a 2. That is going to be a vertical stretch, because my amplitude is 2. All my x-intercepts stay the same, but I'm going to stretch all these maximum minimum values. If I were to take y equals 1/2 sine theta, that it's going to be a vertical shrink or compression. All my x-intercepts stay the same, and all these maximum and min values go to 1/2. So it's a vertical shrink. And then the one that students struggle with the most is this idea of horizontal stretches and shrinks. It's if I change the period by changing this b value. So if I change b value to 2, then what happens, this is going to be a horizontal shrink, because my period is now 2 pi over 2, which is equal to pi. So the way I graph that, remember my original function starts here and ends here at 2 pi. So now I want it to start here but end at pi. Before, halfway across it went through the x-axis again, so there's the halfway mark. Halfway between here I had a maximum, and halfway here I had a minimum. So that's what it would look like for one cycle. And then I can continue that. And once you get the pattern, it makes it easy. If I have y equals sine 1/2 theta, and don't worry that I'm going between theta and x, it doesn't matter. I'm going to have a horizontal stretch And the reason this becomes a horizontal stretch is my period has changed. 2 pi over b, b is 1/2, so it's equal to 4 pi. So I start at 0 and I end at 4 pi. Well, I didn't have 4 pi in the graph, I'm going to stop, just kind of sketch it out there. Halfway between, I have another 0. Halfway between these zeros, I have a maximum. Halfway between these zeros, I have a minimum. And then the pattern continues. So that is what a horizontal stretch looks like. And then a cosine graph, of course, has all the same characteristics, so I'm not going to spend a lot of time going over everything else. I'll just give you the horizontal or the cosine graph. So cosine graph, if you think of your unit circle again, actually let's just go back to where I had it drawn. Now the cosine is the x values. So at 0 we have 1, at pi we have -1. Pi over 2 is 0, 3 pi over 2 is 0. So at all the multiples of pi over 2, I'm going to have 0. It starts out, 0 has 1, pi has -1, and then it flops back and forth as well. So that is what a cosine graph looks like. The domain is the same, the range is the same, the amplitude is 1, the period is 2 pi, and the key points are going to be my zeros, which are the x-intercepts, which is at all the multiples of pi over 2, my maximum points, which is at 0, 1, 2 pi 1, and my minimum points, which -pi, -1, pi, -1, 3 pi, -1.